To begin with these warm-ups, we're going to figure out what's missing to make one whole. So 66 plus 34 would make 100 hundredths, or one whole. Here, 83 plus 17 would give us 100 hundredths, or one whole. 1/5 plus 4/5 gives us 5/5 for one whole. Please finish the remaining problems in your composition book. About 2,000 years ago, the Roman Empire was a vast territory. To maintain the empire, taxes were collected from its citizens. Initially, the tax system was very unfair because it relied on people called tax farmers to collect taxes in an area called a province. These tax farmers prepaid the estimated taxes for their province and then kept any extra money they collected from the citizens, basically stealing the citizens' money. Tax farmers were able to get rich quickly this way. Roman Emperor Augustus Caesar stopped the process of tax farming and taxed Roman citizens more fairly. Roman citizens earned income and paid taxes with silver coins called denarii. One of them is pictured here. Imagine that you are the Emperor of Rome, and you want to tax the citizens fairly. How much would you tax each of the following citizens? Explain your thinking. So citizen A earns 225 denarii per year, citizen B earns 375 denarii per year, and citizen C earns 3,750 denarii per year. In my class, someone brought up that we could tax them all 5. But if citizen A makes significantly less than citizen C, that impact is going to be a little bit different for those people. So another student brought up that we could look at how much they make in comparison to one another and tax them accordingly. So somebody mentioned that citizen B and citizen C would have 10 times as much as citizen C or citizen B. So we could tax citizen C 10 times however much we taxed citizen B. And we came up with taxing them all a percentage. One class said 5%, another class said tax them all 10%. But basing it on a percentage makes it fair for all 3 of these citizens. Here is the original symbol. You can see there's some similarities with the 2 circles and the line, but now our symbol looks a little different. This is our traditional percent symbol. What do you think this one would mean? If this is per 100, this one would be per 1,000 and per 10,000. This one is called a percent. And then we have these 2 new words to describe the 2 additional symbols. How can 80% be expressed in permille? If it's now out of 1,000, we would multiply by 10 on the top in the numerator and in the denominator to create an equivalent fraction. So 80% would be 80 permille. How about permyriad? We would need to multiply by 100, which would give us 8,000 permyriad. In this picture, what is it something that you know for sure? We know it's not fully charged. We know it's less than half or less than 50%. We know it's between 0 and 50% because it's not fully to the bottom. But we don't know exactly what percentage this represents. It may be 42%, or perhaps it's 44%. We don't know the exact percentage, but we do know that it is less than half. So here is that picture in a tape diagram type setup. The tape diagram represents the remaining charge of a cell battery or a cell phone's battery. What percent of the battery charge does each unit in the tape diagram represent? If we split up 100 into 5 parts, that would give us 20 at each part. So 0, 20, 40, 60, 80, 100%. So each section or each unit of this tape diagram represents 20%. What fraction represents the battery's remaining charge? We have 40 out of 100. That is for the remaining. Then it asks what fraction represents the battery's charge that has been used. We have used 20, 40, 60. So what percent remains? That would be 40% remaining. And what percent has been used? The following students estimate the number of hours in their cell phone battery, the hours their cell phone battery will last when it has a whole charge. Ryan's phone battery lasts 10 hours. How many hours will Ryan's phone last when the battery's remaining charge is 40%? Draw a tape diagram to determine your answer. Recall from the last slide that we had 2/5 to represent 40%. So we're going to have 5 boxes and shade in 2. So we know that the whole tape diagram represents 10 hours. If we split 10 into 5 boxes, that gives us 2 for each box. So how many hours will Ryan's phone last when the battery's remaining charge is at 40%? It will last 4 hours. Kayla's phone battery lasts 15 hours. How many hours will Kayla's phone last when the battery's remaining charge is 40%? Draw a tape diagram to help you answer. We have 15 split up into 5 parts, which gives us 3 per box. So Kayla's phone will last 6 hours. Riley's phone battery lasts 8 hours. How many hours will Riley's phone last when the battery's remaining charge is 40%? The whole thing is 8, but we split it up into 5 parts. That is 8 over 5. I'm going to leave it as an improper fraction until the end. So 8/5 plus 8/5 is 16/5. 5 fits into 16 3 times because 5 times 3 is 15. And then I have one more to make 16. You can think of 1/5 as 2/10, which is also 3.2 hours. For Lacey's, it lasts 6 hours. 6 divided by 5 is 6/5. 6 plus 6 is 12. So here we have 12/5, which is 2, because 2 times 5 is 10, plus 2 more makes 12, or that's the same as 2 and 4/10, or 2.4 hours. In this next section, we're going to write the remaining charge and the total charge. So in the first one, the phone lasted for 10 hours when it was fully charged, but when it only had 40% remaining, it lasted for 4 hours. Then we had 15 hours of full battery charge, and it lasted for 6 hours on that 40% left. We had 8 and 6. This one was 3.2, and this one was 2.4. We're just filling in that table with the information from parts A through D. For problems 6 through 9, solve by using any method. I'm going to teach you my favorite method, and it is called cross multiply and divide. So the way that I set up my fractions uses this relationship. Part, whole, percent, and 100. So 13 out of 20. 13 would be the part, and the whole in this case would be 20. So for cross multiply, we're looking for ones that are diagonal from each other. We are going to multiply these two. And then we divide by whatever number we haven't used yet. So 13 times 100 would be 1,300. And then divide that by 20, which is 65, and that is our percent. For this next one, we're going to use the same setup. Part, whole, percent, and 100. We're looking for the percent, so that one's going to stay there. The part this time is 18, and the whole, see how it says that word of 36? The word of in these problems typically indicates the whole. Cross multiply, we're looking for the ones that are diagonal from each other. Then we divide by the number we haven't used yet. 100 times 18 is 1,800. Then divide that by 36, which will give you 50%. Same setup here. Part, whole, percent, 100. This time the part is 24. Out of, that word of shows up again, 80. That would be the whole. We are going to cross multiply. Then divide that number by the number we haven't used yet. And that will give you 30%. Another way that you can do these problems is if we did 17 divided by 85. That gives us 0.2. That's the decimal version. To turn it into a percent, we move that decimal 2 spots. So this would be 20%. So just a couple of different ways to approach this problem. I prefer the cross multiply then divide strategy because it works for everything. And I can put the percent in there if I know the percent and I'm missing one of the parts or one of the wholes. So this setup works for all types of percent problems. Using a double number line here, you can see they start at 0 with both and they go to 100%. Kind of like in the tape diagram, but with the double number line, it's just the number line stacked on top of each other. For number 10, we are going to use a double number line so you can see an additional strategy for solving percents. Noah set a goal to eat at least 80 grams of protein each day. Today he eats 90 grams. What percent of his goal does Noah eat today? Draw a double number line to show your thinking. So we have grams and we have percent. His goal was to get 80. And then he ate 92. Did he get more than his goal or less than his goal? 92 is more than his goal, so he's going to actually eat over 100% of his goal because 80 is the whole that we were looking for. All right, in order to get to 92, we're going to need to split it up. I see that we have 100% is 80. Let's break it up into 50%. 50%, half of 80 would be 40 grams. And if we break it up even further, maybe we could do 10%. This would be 10, 20, 30, 40. 50 split into 5 parts is 10. 40 split into 5 parts would be 8. So we keep this going. We would have 48 grams, 56 grams, 64 grams, 72, 80, and then we're going to have to go past that. So 110% would be 88. 120% would be 96. But we skipped 92, so we're going to have to break it up even more. If we went and did 5%, that would give us 4, because half of 10 is 5, and half of 8 is 4. So we could split this up and do 105% would be 84. 115% would be 92. So, what percent of his goal does he eat today? Noah ate 115% of his goal. Now, that took a long time, in my opinion. So that's one of the other reasons that I prefer the part whole percent 100 setup, because it would look like this. His goal was 80. Percents are always out of 100. He has a part that is bigger than the whole, and that's because he ate more than his goal. But if I cross multiply here, 92 times 100 gives me 9,200, and then I divide by 80 because that's the number that's left, and I still get 115%. but it's a much faster process to get to that answer. So it is okay to have a part that is bigger than the whole. In number 11, it says 18 is what percent of 15? Remember, I told you that of is a good indication of the whole. 450 out of 150. We're looking for that percent. Cross multiply, then divide. Cross multiply, then divide. Try these on your own. You can use a calculator if you need one, and then come back and check and see if you have the correct answer. Pause the video here for additional time. Same with these. 21 out of 20. Looking for the percent, which is always out of 100. 675 out of, there's that word of again. Percents again are always out of 100. Cross multiply and divide by the number that you have not used. Pause here, try them out on your own, and then come back and check.